y prime equal to y plus x over x. Hold on. Okay. So, yeah. So you see here, y power 1, x power 1 divided by x power 1. So the power, okay, for each term are same. So hence, okay, this one is guaranteed this is homogeneous equation. But if the equation, okay, like this one, already mentioned this homogeneous equation. So, okay, confirms the given differential equations, okay, are homogeneous, then you no need to go through that process where you replace x by lambda x, y by lambda y, and prove that, okay, so mean you no need to go through, okay, just now the process. Yeah, I think my word cannot write in the word. Hold on. Search back the PDF. Exercise 1C. Okay. Okay, so means, okay, okay, I cannot write. Okay, hold on, some technical problem. Okay, okay, you have the, okay, fxy is actually when you have the forms dy dx equal to fxy. So the fxy, okay, in this case is y plus x divided by x. Okay, the proper way to show that this is homogeneous equation is actually x you replace by lambda x, y by lambda y. So you see lambda y plus, this is lambda x divided by lambda x. So each term you have the lambda where we can cancel out. Then we get back, this is y plus x divided by x, okay, or lambda power 0, which is actually 1. So y plus x divided by x is your fxy. Okay, hence, okay, this is actually homogeneous equations. Okay, the short form of homogeneous equations. Okay, but if the equation already mentions this is homogeneous equation, actually you no need to show this step. You can directly solve it. And then you see, okay, shortcut, as I said, okay, for homogeneous equation, normally the power for each term must be same. Here's 2, 2. Okay, so x power 1, total is power 2. Okay, and here you see this is xy and then y times y. So total is power 2. So divided by x squared is power 2. Okay, here y 2x squared y total is power 3. This term y cubed total is power 3. This is divided by 2x cubed total is power 3. So each term is power 3. Okay, and here power 1, power 1. So power 2, power 2, power 2, you square it, you get power 1. So this is power 1, power 1, power 1, power 1. So shortcut, okay, without going through, okay, substituting x equal to lambda x, y equal to lambda y, and prove that you can get lambda power 0 fxy is actually for homogeneous equation. Okay, the power for each term must be same. Okay, after that, what you can do is actually, okay, question 1a, you have a y prime is y plus x divided by x. So y prime, okay, and if this is homogeneous equation, you use y equal to vx, and then so okay y prime or dy dx, okay, using product rule, you get v plus x dv dx. So y prime is replaced by v plus x dv dx. Okay, y by vx. Okay, and we can, so x, 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 you can simplify. We just left, okay, when you cancel, okay, some of you may careless mistake your tensor. This one is actually, okay, when you cancel here, this one you still have 1. Some will, okay, with careless mistake, we just left v only. So v plus x dv dx you get equal to v, am I right? Okay, v plus 1. Then x dv dx. Okay, left side you have v, right side you have v. So x dv dx equal to 1. So after you substitute y equal to vx and dy dx equal to v plus x dv dx, after simplifications, you will left in term, it becomes separable equation in term of v and x. Okay, this is 1. Then you have only dv equal to dx over x. So now you can integrate both hand side. So integrate 1 dv, we have v. Integrate 1 over x, you have ln x. Okay, since ln, I can put the constant in terms of ln c. Okay, and lastly, replace back v is actually y over x. Okay, so ln x plus ln c become ln cx. So y is actually x ln cx. So this question is more is simpler. So do you have any questions here? If not, I would like you to try to do question 1b.